Unit 4, Learning Target number 7. Reflect points over the x and y axis. What is a reflection? When you think about reflections, you may think of a mirror, or maybe a pool of water like we have here, that reflects whatever is, in this case, above it into the water below. And in math, reflection is very similar to that. Now let's lay the coordinate grid down on top of our picture, and let's see what it looks like. Now you can see that the x-axis, right here, we have our x-axis along the bottom. Our x-axis is right where the water line is. And you can see that if I were to put a point right here, then the reflection of that point is directly below in the exact same place. That is exactly what we mean by reflection we're talking about in math. We would take a point and reflect it over the x-axis to get it in the exact same point on the other side of the axis. And we can do the same thing over the y-axis. Now this picture isn't perfect, but you can see that this point is almost in exactly the same place on that side. We can reflect points over the y-axis as well to get them in exactly the same position. And since we're dealing with our reflections on the coordinate system, we can talk about our different quadrants, 1, 2, 3, and 4. You'll remember that in quadrant 1, all of our points are positive on the x and positive on the y. In quadrant 2, they are negative on the x and positive on the y. Quadrant 3, they are negative along the x-axis here. They're going this way, and negative along the y-axis as well. Then in quadrant 4, they are positive along the x-axis right here and negative along the y. So in this case, we have taken this point right here, we'll call this point A, and we have reflected it into quadrant 1 across the y-axis. Reflected point A across the y-axis into quadrant 1. Then, in this case, we have taken point A and reflected it across the x-axis into quadrant 3. So now let's take a look at reflection on an actual coordinate grid. The first question is, what do point A and point B have in common? Here's point A and here's point B. Well, if we look at their coordinates, it looks like their y-coordinates are the same. The y-coordinate for A is 2 and the y-coordinate for B is also 2. What is different between the two is their x-coordinate. Their x-coordinates are different. In A, though they look the same, A has a -3 and B has a +3. Remember that our coordinates for the first quadrant are positive, and our coordinates for the second quadrant are negative and positive. Now it makes a lot of sense that our y-coordinate is the same because we are reflecting these across the y-axis. Our y-coordinates stay the same because they're reflected across the y-axis. A is reflected across the y-axis to point B. And if you look down as we reflect A across the x-axis here, so here is our x-axis, if we reflect A across the x-axis, now the x-coordinates are the same. So here, -3 is the same, and -3, and the only thing that changes is the y-coordinate, which is now negative. And now we can use the coordinates of C, or B for that matter, to find the coordinates of point D, which we don't know yet. We can see that point D is a reflection of point C across the y-axis. So which coordinates will stay the same? Well, in this case, the y-coordinates are going to stay the same because we're reflecting across the y-axis. So this is going to be a -2. And the x-coordinate is going to change. It's going to become the opposite of point C. So the opposite of point C, which is -3, its x-coordinate is -3. The opposite of that is +3. And if you remember, that makes exactly the correct sense because if we recall in quadrant 4, all of our signs are positive, negative, positive, negative. Let's take a look at a couple of problems. Let's reflect some of our points over an x-axis, and I'm going to move me up here so I'm a little less visible and we can still do our work. Let's reflect point 35 over the x-axis. So we're told that we're going to take point 35 and reflect that across the x-axis and find what the points are. So let's find point 35 first. We need to travel 3 positively along the x-axis and then up 5 to get our point. That is point 3, 5. Now we need to find the reflection of that across the x-axis. So which coordinate is going to stay the same? Well, since we're reflecting across the x-axis, the x-coordinate will stay the same. And the y-coordinate will then become the opposite of its previous coordinate, so negative 5, when we reflect across the axis. So we're going to look for 3, negative 5, and that is right there. 3, negative 5. Now, is that the opposite? Well, yes, they are in the exact same place on opposite sides of the x-axis. And if you look down here, we'll take the next problem. We're going to take negative 5, 2, and we're going to reflect that across the y-axis and see what coordinates we get. So first of all, let's plot our coordinate, negative 5. So we travel negative 5 along the x-axis and up 2 along the y-axis to get negative 5, 2. And we are asked to reflect that across the y-axis. Across the y-axis, so it means it's going to be in quadrant 1. So, since we're flipping across the y-axis, which coordinate is going to stay the same? That's going to be the y-coordinate is going to stay the same. So that's going to be 2. And the x-coordinate is going to be the opposite of where it was before, so that's going to be a positive 5. So let's see if that makes sense. Come over here, we start at 0, and we move over to positive 5, and we go up 2, and this is our new point. Now, is that the reflection of that point? Yes, it is. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're the same distance away from the y-axis. Now you can see sometimes you'll be asked these questions and you won't be given a coordinate system to kind of look at for reference. So let's take a look and use what we know to solve these problems. So we are asked to reflect 3, 2 across the x-axis. So remember what we learned. We learned that when we reflect across the x-axis, which coordinate stays the same? That's right, the x-coordinate stays the same. And then the y-coordinate, so if this is the x-coordinate, this is the y-coordinate, the y-coordinate then changes to its opposite when it is reflected across the x-axis. So our new point is 3, negative 2. Reflecting negative 4 across the y-axis, in this case, we are going to, well, which coordinate stays the same? Since we're going across the y-axis, our y-coordinate stays the same, so that's going to be negative 4. And then our x-coordinate is going to change to its opposite, so we'll be left with 4, negative 4. And that is all there is to it.